I'm now delighted to be joined in the studio by Tom Cox to tell us all about electrical and electronic engineering at the University of Nottingham. And I'm equally delighted that we have Liyou, who has just completed her final year with us too. Thank you, both of you, for coming. So Tom, first question for you. Why should someone consider studying electrical and electronic engineering?
So the reason I would say you would want to be doing electrical electronic engineering is it's an amazing subject with an amazing growth potential. So it's very much a hidden subject that's supporting everything we do. We're in a studio right now, we have lights, cameras, all kinds of systems, and all of these are underpinned by electrical electronic engineering. Every aspect of the modern life is supported by electrical electronic engineering. So it's something that is an amazing but often hidden subject. You plug something into a wall, you don't always realise that behind that plug socket there's an enormous system of power supply, of transmission, generation, taking power from somewhere remote in the North Sea, from another part of the continent, supplying that direct to you. It's all hidden, but it's all there, and it's all supported by electrical electronic engineering. And the future's just getting more amazing, with growth in renewables, with growth in vehicle electrification, and with the upcoming sort of AI developments. This is all driving it as a much more interesting and much more engaging and rewarding subject.
And Lee, what was it for you that made you want to study this course?
To be honest, I wasn't that interested in electrical electronic engineering initially, and I even took a year off right after the first semester because I found it was too challenging for me. And I was very interested in biology, and while I was in the break, I went to a brain computer interface lab, but I was doing the brain side stuff. But as I watched those PhD students, they're doing something really theoretical projects, and I just realized that wasn't the path that I want to go in. I wanted to work on the biotechnology thing that has a physical impact. And that's how I reconnected with electrical electronic engineering with a new perspective that I can use this field as a bridge to combine biology and physical device. Yeah.
And as an international student, what was it about the University of Nottingham that appealed to you?
Because I'm from China, and there is actually an international campus right in front of my house. So it just being a very natural choice to me when I'm thinking to study abroad. And I know University of Nottingham has a strong global reputation and diverse international communities. So why not? Why not take the advantage to study in such a good place?
And Tom, obviously there's so many different courses available in the department. So can you give me a brief overview of what you might study?
So we have a lot of options for years abroad and years in industry, but the fundamental course strands are electrical and electronic engineering, electrical and electronic as their own subject, and electronics and computing. So electrical and electronic engineering very much works on the sort of interface between power and information. So when we talk about those two subjects, we have power, which is looking at how we power anything, how we get some kind of motion, heating, lighting, so how we do power to do useful mechanical work. The information side is how we process information, how we do computing, sensing, feedback, communications. And those are two interlinked subjects. So both of those subjects form a key part of our curriculum, and depending on what you do, you may specialise more into one area or the other later in the course, depending on electrical, electronic, or a mix of both. And then the electronic and computing strand is a little bit different. So that's a strand for people who might be interested potentially in computer science, but also want to learn more about the hardware. So that's a strand that very much focuses on both the software and programming elements of computing, but also on the hardware side, on how you would actually design, optimize the hardware to run those systems, whether it's a personal computer or whether it's a huge data center for AI processing.
And this is a subject where, you know, there's going to be so much changing all the time. So how are you adapting to emerging trends in the industry?
So the way we adapt to emerging trends, so we have some really good support from our industrial partners. We have an industrial advisory board, so a bunch of people from industry who review our courses, who are very good at looking at how we're progressing in our course and also give us some direct support. We follow trends in the industry Also through our module structure, a lot of our teaching material in the first 2 years is core, and one of the things we do is, because we recognise that by the third year you would want to make choices, you would want to actually choose career paths and choose modules that suit what you want to do for the rest of your life, we need to give you that overview of the sort of broader field of engineering. So we have modules in year 1 and 2 called contemporary engineering themes, and those are designed to actually bring in specialists in emerging areas. That might be artificial intelligence, vehicle automation, electrification of aircraft, satellite communications. The subjects vary year on year, but that keeps our curriculum up to date so that when you get to make those choices on modules and ultimately careers in your future, you've learned everything about all of those different paths and you're very aware of the kind of things you want to do. And then on top of that, to keep our modules fresh, we also have some world-leading research groups associated with the department, and that means the people teaching your modules are actually working on technology that's currently being implemented in next generation systems, aircraft, cars, power networks. And so we're teaching our cutting edge material based on what we're actually doing, not what we learned 20 years ago.
And Lee, what was it that you most enjoyed about doing this course?
I think it's about I got lots of choice to do. As Tom just mentioned, we got contemporary engineering themes. I know the latest thing happening in the field that I can choose from, and every stuff is so accessible, and they're being friendly and always ready to help me to guide what I actually like, what everyone really like, and I got lots of chance to choose what I want. Yeah.
And you mentioned there, Tom, some of your world-leading partners that you work with. So what are the opportunities for students if they want to work on projects or placements during their time at the university?
So we have a lot of integrated project work within the programme. So a core part of our year 1 and year 2 modules is actually based on project work. So about 1/3 of your academic year with us in year 1 and year 2 will be in our project labs. So we have custom-built project labs which are designed around supporting our teaching methodology. So when you join us for year 1, you'll have a mix of teaching weeks which are similar to what you do with most universities, but also project weeks where you wouldn't do lectures, tutorials, other classes. You'd actually be 9 to 5, Monday, Tuesday, Thursday, Friday, working in our project labs with your peers. So in year 1, you'd be working on an autonomous vehicle platform. So while we're teaching you about the different aspects of electronics and communications and power and systems and programming, you're actually putting those into practice on the autonomous vehicle platform. So every few teaching weeks, you'll then have a project week, and you'll actually be able to apply this learning by doing methodology. And on top of that, pick up the essential practical skills around design, error checking, fixing systems. And then later on into the course, we have continued practical opportunities to work on individual projects in your final year, to work on a industry-led group project if you do a third year with us as an MEng, as well as other smaller practical experiments throughout the course. We are very much a practical, hands-on focused course.
And you sort of went into it there, but how can students benefit from all the facilities that there are on campus in terms of, labs and workshops, things like that?
So we have our core teaching facilities which we use for those activities, but we also very much want to support our students with other activities. So for specific teaching activities, we have spaces. So we have our main teaching project labs. We also have final year project labs, so dedicated space for you to work in. We have a dedicated technical workshop and a technical team who are just related to our department, and they're there to help you out both with the projects that are in your timetable and also your own projects. They're very keen to help and support you. We have electronics, 3D printing facilities, and we can support those. We also have what we call hack spaces. So we have 2 labs which can be used for general purpose activities. That might be catching up on a piece of work from one of your projects, but it might also be working on projects in your own time, giving you the space to actually come in, do some work with reasonable facilities, with power supplies and scopes and the equipment you need to do your own projects.
And in terms of, securing a job when you graduate, how do you prepare students for that?
So employability-wise, our course is very good. We do very well. I think one of the key things is those growth areas I talked about before. Areas like automotive, renewables, AI are really driving that market. So we're preparing our students by giving them a huge amount of practical hands-on experience, by teaching them in a way that's guided and supported by our industrial advisory board, by people who are recruiting our graduates, telling us what the skills are that our graduates are looking for, keeping our curriculum up to date. Modules like our CET programme ensure that the students are aware of the latest technologies and the latest developments, and ultimately we're aiming to produce competent practical engineers with a wealth of hands-on experience that are able to get into the workforce and actually work practically on projects with a lot of sort of competence and ability.
And Lee, as we just heard, you've recently graduated from this course. What are you up to now?
I'm actually doing a PhD in the University of Nottingham right now, and I'm focusing on photonics. Specifically, I'm working on a imaging technology that can deeply penetrate through skin and diagnose disease or deliver medications. And it's really exciting to work on such thing that combine biology and physical world to create a real world solution.
And I think finally a question that I'm sure both of you will be able to answer. What advice would you give to anybody watching this that's thinking of applying for this course? Tom, we'll start with you.
So I would say there's a few things. Try to come to open days if you can. They're a great opportunity to actually come along and look at subjects, and especially to look at multiple subjects. We have open days set up so that you can come along and look at different strands of engineering or different areas of engineering and science and computer science. So you can come along and get a view of what you might want to do. And also seeing where you want to go is essential. I would say try your best to sort of learn all you can to look at where you want to go and find a place that fits. Don't make decisions based on very small differences in league table metrics. Ultimately, find a place that you like that feels right for you, because it's where you're going to be for the next few years. So make sure that you enjoy it. And I think the final point is, when you're looking at all these many course choices, bear in mind there is a lot of flexibility. We have a lot of options to sort of transfer between course strands. So if you're sort of overwhelmed by 30 plus course choices, bear in mind that if you join us on one of those strands, it's a very simple and easy process to transfer onto another one of those strands.
And Lee, what about you? I'll say just don't panic, because you might find your classmates, their YouTube got thousands of followers, or those who are start doing projects when they were still young. If you can't find what you are actually really interested in, and that's fine, just go explore yourself, just go talk to the staff. They are all very nice, and I'm sure you can find what you are actually interested in the University of Nottingham.
I think very good advice there. Thank you so much, Tom and Lee. The link in the schedule below will take you to more information about electrical and electronic engineering on the website, and send in any questions that you have using the QR code.